Here's a look at the solution to Chapter 9, Question 7. Solve each of the following inequalities for the given variable. Represent your solution on a number line. So the strategy we've talked about in terms of solving inequalities is that we need to find the boundary location. And once we've identified the boundary location, there's one of two symbols we'll use. In the case that you've got, like here, this is strictly greater than, this would be an open boundary point. Just an open circle, not shaded in. In the case that you've got less than, this would also be an open boundary point, right? Open circle on the number line, not shaded in. And in the case that you've got either here greater than or equal to or less than or equal to, the or equal to indicates that that boundary point actually is a solution. So on these, we would have filled in dots, which means not only is this the pivot point where our solutions are, but also that point itself is a solution. So let's take a look at the first one. To identify the boundary, what we do is we just treat this as an equation. So I'm going to go ahead and distribute the 2, and I'll write this as 6 times p plus 2 is equal to negative 4. If I take away 2 from both sides, I've got 6 times p is equal to negative 6. Therefore, p is negative 1. So my boundary location is at negative 1, and I'm going to have an open boundary there. So on a number line right here, I've got an open circle at negative 1. And now we need to test and see if we're going to go either to the right of that boundary point or if we're going to go to the left of the boundary point. And to do that, we test a value. If we test a value and it's true, it's going to go on that side. If it's false, it's going to go on the opposite side. My favorite point to test always is the number 0, just because the arithmetic's easy. So if I test x is 0, right, this is on the right-hand side. If x is 0 is true in my original inequality, then the right-hand side gets shaded. If it's false, that means my solutions are on the other side, and I would shade the opposite direction. But when I come back in and I put 0 in for this value of p, this becomes 2 times 1. And it is true that 2 is always greater than negative 4. So because this is true, right, I know 0 is the side with the solutions because that made the original inequality true. So that means that we're shading everything in up above that point. So these are all my solutions, right? Everything to the right of the boundary point, but not including the boundary point. Let's do part B. Part B, I'm going to go ahead and solve again. So I'll just rewrite this as 9k minus 2 is equal to 3k plus 10. I'll take away 3k from both sides. And when I do that, I'll pause and just think, did I really subtract 3k from each side? Yep. Now I'm going to add 2 to both sides. Yeah, I added 2 on the left-hand side. Negative 2 and 2 is 0, and I added 2 on the right-hand side. And then I'm going to divide both sides by 6. And I did do that. Both the sides were divided by 6. So my boundary location is at 2. And at that boundary, I'm going to have an open boundary, again, because it was strictly less than. So at 2, we have our open boundary. And then our question is it going to be to the right of that or to the left of that? You can see my favorite test value, 0, is here. It's available. It's always available unless your boundary point is 0. Then you're going to have to pick some other test value. But in this case, 0 is available as a boundary point to check, or it's not a boundary point, so I can use it as my check. When I put 0 in for k, 9k, and here, those both become 0. So this becomes negative 2 is less than 10, which is true. So that means the side with the 0 is going to be shaded in. So I'm going to be shading this time below. So everything to the left of my boundary is a solution, but not my boundary itself. So even like the value negative 0.5 or 0.5 or 1.5, all of those will work. Anything just to the left of it. Last problem is, oh, look at this. We've saved the most challenging one for last, right? So I'm going to, let's see. I'm going to take away 5 from both sides. So let me erase this. So when I take away 5 from both sides, I get the opposite of h is greater than or equal to, whoops, it's going to be an equation, right? So is equal to a -1. So I look at my original equation, right? I was treating this as an equation to find the boundary. And when I took away 5 from both sides, I got the opposite of h is -1. And I don't care about negative h rather, I care about h. So I'm going to multiply both sides of this equation by 1. And when I do that, I get that my boundary is located at h is equal to 1. Okay, so h is equal to 1. 1 is my boundary, and because this was less than or equal to, right, because of this symbol, this time the boundary is shaded in because it's included. So at 1, we're going to go ahead and include, we're going to shade in the 1. Shade in the positive 1. Positive 1 is a solution. Then the question is am I above that or am I below that? And again, my favorite test value is available, 0. So I'm going to come back in and I'm going to plug 0 into the original inequality. When I plug 0 in there, it becomes 5 minus 0, or 5 is greater than or equal to 4, which is clearly true. So that means I am going to be shading on the side with the 0, right? All of the values below are solutions. These points all work. And I could pick any arbitrary point that I want. For example, if I picked -7, that would be a solution. 1 would be a solution. 6 would be a solution. Let's check 7. If I put 7 in there, this is going to become 5 minus -7, right? Because I'm plugging in -7, which is 12. And 12 is, guess what? It's greater than or equal to 4. So all of these points below are solutions. So if I was to summarize again, let's write what our actual solutions are. This one is x's are those things that are greater than -1. This is my solution. X's are greater than -1, except they weren't x's. I think these were p. P's are greater than 1. The next one, we had the variable k, and then just looking at the graph, you can see that k's are those things that are less than 2. And then for the last one, this was the variable h, and you can see that h are those things that are less than or equal to 1. Again, my boundary point here is shaded, so I include the endpoint.